Good morning, good afternoon, good evening, everyone. My name is Sagar Deshpande. I'm the product manager for Cambium Networks. Today, we have an interesting session about introduction to 60 gigahertz, talking about Terragraph technology and why 802.11ay is better than 802.11ad. With me, I have David. He's from David. Can you introduce yourself and share a little bit about yourself?
Sure, thank you. Good morning, Sagar. Hi, everyone. David Bueta. I'm with Facebook Connectivity, our strategic partnerships group, and I look after relationships with vendors, OEMs, and strategic partners around a variety of connectivity projects that we run. Very excited to be here, and thank you to the Cambium team for inviting me to join.
Thanks, David. We also have Alan Yu. Alan.
Hey, good morning, good afternoon, good evening, everyone. It's Alan Yu. I'm the product manager of Cambium, responsible for 60 gigahertz, and I will respond for Q&A session today. If you have any questions, feel free to post on the panel, and we will get all questions addressed after the webinar.
Right. Thanks, Alan. So in this webinar, we'll be covering and understanding more about Terragraph. What is Facebook connectivity? What are the advantages of Terragraph? We'll also be talking about Cambium Networks as a Terragraph OEM partner, and also spend some time talking about some proof of concepts of Terragraph deployments that were recently conducted. Next, we will spend a few minutes talking about Cambium Networks, multi-gigabit wireless fabric, and introduce cnWave and Wi-Fi 6. Also focus on advantages of 60 gigahertz and some of the factors that are affecting it. Lastly, we'll try to understand the 802.11ay standard by comparing it with 802.11ad standard and providing some technical advantages of 802.11ay. As Alan mentioned, we will have a Q&A session at the end of presentation. So please write your questions in the chat window and Alan will moderate this discussion after the presentation. Okay, back to you, David.
Thank you, Sagar. So to start, let me give a little bit of background on Facebook connectivity. In this webinar, we're going to talk about Terragraph and Cambium's partnership with Facebook to basically bring Terragraph technology to market. Now, Terragraph is a project that comes out of the Facebook connectivity group. Not everyone might be familiar with this group. It's a group within Facebook that has a mission to bring more people online to a faster internet, as shown here. And if you think about this mission, our Facebook corporate mission is basically to give people the power to build community and bring the world closer together. So if you think about that, connectivity and especially access to internet is a pretty fundamental piece of that. Of course, our family of applications at Facebook depends on good connectivity, hence the existence of this group and the mission that we drive. We drive towards this mission through a variety of different projects, technology programs, and so forth at Facebook. And Terragraph is one such program that we've actually partnered very closely with Cambium on. Maybe I'll describe a little bit about what Terragraph is. If you could proceed to the next slide, please, Sagar. Thank you. So you can think of Terragraph as effectively a bunch of intellectual property, that is specifications and software that define a technology which allows a fleet of radio nodes which operate in the 60 gigahertz spectrum to form a mesh distribution network which can deliver fiber-like speeds, but at a fraction of the cost of fiber and also at a much faster deployment speed. Basically, if you can deliver fiber-like speeds and remove the hurdles associated with fiber, which are typically rights of way, trenching, and so forth, the promise of delivering fiber-like speeds at fractional costs is obviously of interest to a mission like we have at Facebook connectivity. Now, what does this say bundle of intellectual property consist of? It's captured here to some extent. So Terragraph operates in the 60 gigahertz spectrum. We'll drill into that in more detail. There's a mesh component, right? So these radio nodes mesh to one another, and the mesh algorithm in Terragraph actually leverages a routing solution used in Facebook data centers called OpenR. It's highly scalable, very resilient, fast failover. and we found it to be very applicable to this type of radio network. The Terragraph specification or IP also addresses the medium access control, the MAC layer. It's a time-sliced TDD, TDMA MAC that allows for a very efficient use of spectrum and is especially important when you have a high density of radio nodes and point-to-multipoint connections. The IP stack also includes cloud management or network management solution. And then given the complexity involved to plan a millimeter wave mesh network, we've also got some IP around network planning. Now, I keep referring to this as IP because what Facebook does to actually enable or commercialize this technology is work with partners like Radwin, who are licensees of the technology. So Facebook is not directly in the business of selling or producing radio equipment. We're not a vendor. We don't have aspirations to be one, nor are we a service provider. We actually license all of this technology free of charge to partners such as Cambium, and ultimately are invested in their success bringing this technology to market. Next slide, please, Sagar.
Right. Thanks, Dave. So Cambium Networks is working closely with Terragraph Connectivity Technology as the OEM partner to create a unique 60 gigahertz solution based on the parameters and metrics shown by David in the previous slide. Our 60 gigahertz solution is called cnWave to provide high-speed gigabit connectivity to customers for a for Cambium Network has been closely working with Terragraph team for a long time, and this article that we have published mentioned in February 25th, 2019. So it's been about a year and a half, and we are extremely excited and looking forward to the products with cnWave. Back to you, Dave.
Thanks, Sagar. So absolutely, it's been a very rich partnership with Cambium, and we are extremely excited in the connectivity group at Facebook to see the progress made and the forthcoming 60 gigahertz solutions from Cambium. So to give a bit of broader context on the role we specifically play at Facebook and how we've sort of helped enable Cambium and the broader ecosystem around this technology, I'll talk about these three pillars of focus that we have. One being technology, which really is all the deep R&D, the development that was done within Facebook for engineering work to define the Terragraph technology, at the various network levels, and working with supply chain stakeholders in the ecosystem to ensure, for example, that chipsets are ready, that there are antenna solutions available, making sure that the right sort of compatibility with processors is established. Also make it pretty easy for an adopter or a licensee of the technology to take and commercialize the solution. And then, of course, also in that technology bucket is all the network planning work and the management tools that are developed to ensure that it's easy for a user of a Terragraph network let's say a service provider rather, to plan, deploy, and operate the network. And then critically important is much of the work in the Terragraph, especially the MAC and PHY level, is specification that we've driven towards standardizing. This is important for the ecosystem because as this technology is intended to be usable by a multitude of different stakeholders. We work with several vendors to help them commercialize the technology and also driving the supply chain. It's important to have a standard underlying it. So much of the technology defined in Terragraph has actually been contributed by Facebook into the 802.11ay standard. And we're also working with the Wi-Fi Alliance on a possible certification program for it, much like exists for Wi-Fi. The other pillar of work is around spectrum advocacy, and this is policy type work. In this realm, what we do as Facebook is go to parts of the world where the 60 gigahertz spectrum is not yet licensed, or unlicensed for use. And there we can actually promote and demonstrate the types of value that can be achieved, in a country by unlicensing the spectrum and enabling the connectivity possibilities that it offers. Now, I will say that there are already substantial markets open worldwide where the 60 gigahertz spectrum is unlicensed. Hence the forthcoming launches of product in this that operate in this frequency. So when I mention in this case that we go and work on markets to unlock it, this is for the subset of markets that it's just not yet unlicensed. And then there's also policy advocacy we can do at more local level where we can demonstrate some interesting exchanges, value exchanges, and so forth, and just showcase models of public-private partnership which are possible with Terragraph. And lastly, to sort of round out the work we do on the ecosystem side, it's not just about working with the supply side of things, working with vendors and supply chain, but we also engage as Facebook heavily with service providers worldwide to make sure that the value proposition of Terragraph is understood, that there's a good degree of awareness of the technology. We support our partners such as Cambium in their marketing efforts. And we've actually also launched a number of pilot trials built with running with reference designs or reference solutions that have been developed within Facebook. I'll discuss a number of those shortly, but that's been important work to demonstrate the value proposition both to service providers, in fact, to all stakeholders of the ecosystem, since seeing is believing, and measuring the types of KPIs, key performance indicators possible with Terragraph is important. Next slide, please, Sagar. So we've spoken quite a lot about, some of the background information on connectivity at Facebook, how we've put together this Terragraph program, but what is Terragraph good for? So this slide depicts a few use cases it's good for. I would certainly not call this an exhaustive set of use cases, but here's a set of use cases that would fit, for example, pretty well in a urban or suburban environment, where you have Terragraph nodes deployed on street furniture, such as lamp posts, as you can see depicted on the picture on the right. You can imagine an area covered by a mesh of these nodes, which are mounted on street poles. And once you have that mesh established, the types of use cases that can be supported are fixed wireless access. Now, this could be supported by, for example, hanging what we would call client node radios to the subscriber premises, as you see depicted in blue by the number 1. These client node devices actually connect directly with the mesh. They are 60 gigahertz Terragraph devices. Additionally, on top of those fixed wireless access services, right, and those could be residential, SMB, all the typical fixed broadband subscriber types possible. Additionally, now that you have this fleet of DNs or distribution radios throughout the area, these can serve as backhaul points for either small cells or outdoor Wi-Fi's, use cases 2 and 3 depicted on the slide. Then, of course, there's the suite of smart city type use cases, backhaul for security cameras. So this is a subset. You can imagine that Terragraph is also highly applicable to different campus connectivity use cases, building to building, and so forth. Next slide, please, Sagar. And to demonstrate these use cases and the applicability of Terragraph to them, the value prop that it can offer, Facebook has actually hosted a number of trials and technology proof of concepts using reference platforms that we've built. Now, I will reiterate, we didn't build any sort of solution to make it as commercially available. The solution that we built for these trials has really been just to demonstrate the technology. Ultimately, it's taken the hard work of partners such as Cambium to bring the products that can serve these types of networks into a commercially viable form factor and price point. So using our reference gear, what we've been able to demonstrate, though, these networks, I'll talk about them one by one. First off, in Penang, we deployed with Yes, or their subsidiary company, YTL, to cover a district of Georgetown, which is a UNESCO World Heritage Site. And in this area where Terragraph was deployed, which incidentally is currently the largest Terragraph trial or deployment that we've seen, initially there was actually very limited means of connectivity. It was prohibited to run fiber through this area because of some of the rules around the UNESCO World Heritage Sites, as my understanding goes. So Terragraph was an excellent solution to come in and bring fixed wireless connectivity to residences and SMBs in the area. So that's exactly what we did with YTL, laid out this network. You can actually see a depiction of the network in the sort of map drawing above the words Penang there. Ends up that there were about 30,000 unique users connected to this network. Now, I should say this was a combination of both fixed wireless connections as well as there was a Wi-Fi overlay on this deployment. So of those use cases I showed in the previous slide, 2 of those are actually operational in the Penang deployment of Terragraph. That is fixed wireless over the Terragraph mesh, and then additionally co-located with some of the distribution nodes in the Terragraph mesh are Wi-Fi access points serving public Wi-Fi. And then needless to say that the costs were substantially lower than what fiber would have been if that were even a possibility in the area, and the deployment time very rapid, as we see time and time again with Terragraph, just a few weeks to actually deploy the network. Next, I'll talk about a couple of trials we ran in Hungary with Magyar Telekom, which is a operating company of Deutsche Telekom. Now, in these towns, the residents had the option to connect their fixed broadband service was over DSL. So the opportunity to come with a much higher SLAs as offered by Terragraph basically allowed residents in the area to be upgraded to connections approaching a gigabit per second to the home. And again, very compelling takeaways in terms of cost advantages over fiber, time to deploy. These networks went up in less than 2 weeks each, which was very compelling. And then the availability figures, which was something that Magyar Telekom was acutely interested in. There's often concern around 60 gigahertz operating in unlicensed spectrum. What can the availability metrics be for a say fixed wireless network built over this infrastructure? And we were demonstrating fairly easily 3 nines in Hungary. And then finally, I'll mention in San Jose, this was actually the first large-scale public-facing deployment of Terragraph. I say public-facing as in it wasn't a network built on a Facebook campus, but rather out in more public space. We partnered with the city of San Jose to demonstrate the technology behind a public Wi-Fi use case. So there's a number of Wi-Fi access points basically using the Terragraph network in San Jose as backhaul. And again, the types of takeaways, the metrics were very compelling in this case, not just in terms of the scale of the network, but the cost to do that relative to what it would have been with fiber. And again, the availability figures were very compelling. So with that background on Terragraph, we're excited to see Cambium partnering with us on the program and building up a portfolio that's going to leverage much of this technology. I'll pass back to Sagar to talk more about that.
Thanks, Dave. So I want to spend a few minutes talking about how Cambium sees the multi-gigabit wireless fabric. So in this current scenario around the world, we are seeing an increase in demand for bandwidth as people are either working from home or studying from home. This increase in demand is seen across rural areas as well as urban, and it includes residential as well as enterprise customers. Either they're using it for remote work or video conferencing or etc. This trend has been accelerated due to the current pandemic crisis. The Cambium network portfolio is ready to address this challenge by providing multi-gigabit wireless fabric using a combination of Wi-Fi 6 and 60 GHz, which provides gigabit capacity to homes, offices, and outdoor locations. The Wi-Fi 6 component part is based on the 802.11ax standard, which is capable of providing gigabit capacity, and our cnPilot products are able to address this demand. Now, to provide gigabit capacity to homes, it is important to have multi-gigabit capacity backhauls. So Cambium networks, cnWave, as well as the PTP820 provide the ideal multi-gigabit support to provide high capacity bandwidth. To control all the radio products, we have cnMastro, which is a Cambium network integrated cloud management solution. Using a single pane of glass, you can monitor the entire network. In this slide, we have a few examples of multi-gigabit network. Here, the green lines indicate the backhaul links and the purple lines represent the Wi-Fi deployments or hotspot. In the top left image, we see a city center style deployment where backhauls are connected either rooftop to rooftop, providing Wi-Fi points to apartment buildings or multi-dwelling distribution nodes. In the top right image, we see an industrial style deployment where multi-gigabit capacity is provided to enterprise and industrial customers. In the bottom left image, we see a residential deployment where we are providing wireless gigabit capacity to homes. And finally, in the bottom right, we see 60 gigahertz deployment used as a fiber replacement. Here in this picture, you can see the deployment is near a water body and it is predominantly in an urban area. So if CN Wave can replace a fiber replacement because it is extremely expensive to drill a fiber line, especially near a water body as well as in the city of urban centers. Next, we'll also spend a couple of minutes talking about the advantage of 60 gigahertz. The chart on the left contains frequencies from 900, 800 megahertz to 80 gigahertz, and typically we can divide this entire wide spectrum into three general categories. The first one is 800 megahertz to 6 gigahertz. This is typically your sub-6 band. Either unlicensed, the sub 5 to 6 gigahertz band is unlicensed around the world, or it's specifically licensed for mobile data or fixed wireless data. The next band is 6 to 60 gigahertz, also called as microwave links, and these are traditionally useful for your fixed wireless backhaul. The third one is the 60 gigahertz to 80 gigahertz, also called as millimeter wave links. These links are either unlicensed or lightly licensed, as Dave had earlier mentioned. The 802.11ay based 60 gigahertz solution transforms the fixed wireless access from a broadband option to competitive alternates to fiber as well as cable solutions. So before using the sub 6 or even the LTE band, it was extremely difficult or challenging for broadband providers to compete with fiber or cable. But now with the 60 gigahertz, it's definitely possible. So here are some key advantages of 60 gigahertz. First one, the 60 gigahertz is unlicensed or lightly licensed in most parts of the world that Dave has mentioned. Second one is it has a really wide channel bandwidth of about 2 gigabits per second, 2 gigahertz. This allows for multi-gigabit capacity of data. 60 gigahertz also has a strong oxygen absorption, so the signal does not travel far, which means beamforming is required to connect to the subscriber. This actually in turn improves the security and frequency reuse of the 60 gigahertz, which actually helps in dense area deployments. Next, the 802.11ay standard provides a lower total cost of ownership. Next, I want to spend maybe a minute or so talking about the differences between 802.11ad and 802.11ay. Both of these standards fall under the 60 gigahertz banner. The 802.11ad was ratified in 2016 and the 802.11ay is expected in 2020. The throughputs, this is the 5 physical layer or L1 throughput that you can see. For 1180, it's about 4.6 gigabits per second, and 11AY is double that, about 9.2 gigabits per second. The channel width allocated for 802.11ad is 2.1 gigahertz, and for the 802.11ay standard, it can either be 2.1 gigahertz or 4.3 or double that using channel bonding. The 802.11ad supports CSMA, CA-based collision detection, collision avoidance-based channel access, whereas 802.11ay specifically supports TDMA and TDD. We will be covering this section in a couple of slides later on. The 802.11ad does not have network synchronization. This actually is a hindrance, especially if you want to provide in a dense deployment, whereas the 802.11ay supports network synchronization via GPS. The 802.11 AD does not support mesh, and this again becomes critical, especially if you're deploying a lot of nodes and you want to build in redundancy into your systems. The 802.11 AY supports this one. And one of the most important differences between the two standards is the 802.11 AD supports only 8 subscribers per sector, whereas 802.11 AY supports up to 15 subscribers per sector. This number change alone makes a lot of business cases viable, which is not possible with the 802.11 AD standards. Here's a table that we have that talks about the standards and the current channels that are allocated. So the 60 gigahertz actually is a 12 gigahertz spectrum. It starts from 57.2 to 70.2 gigahertz, and it's divided into 6 equal channels. Each is about 2.16. So in the previous 802.11 AD standards, only channel 1 to channel 6 were defined, each with 2.16 gigahertz. Now with the advent of 802.11 AY, additional channels were added, a channel 9 to channel 13, and each of these channels is double that. So here we see channel 9 is a combination of channel 1 and channel 2. Channel 10 is a combination of channel 2 and channel 3. So channel bonding is basically you take the adjacent channel and then you can use the entire two channels together to form a super channel. So the advantage of using channel bonding is you effectively double your throughput because you're using more bandwidth compared to a narrower channel size. The next one, so let's now talk about CSMA-CA versus TDD and what are the key differences. CSMA-CA is basically you transmit based on, first you sense if there is any traffic or if there is any interference in the network. If there is no interference, then you transmit. If you sense that there is any signal that is coming, you add a back-off timer and then you start the process all over again. This does not scale well, especially if you're deploying a number of subscribers in dense urban areas, or even if you're trying to provide high capacity because a lot of collisions takes place. Whereas the TDMA TDD based 802.11 AY has a completely structured and timely option where each frame has a fixed duration, which has a TX and RX, which is a receive frame and as well as a transmit frame. This ensures that each subscriber gets a dedicated time slot for it to transmit and receive. By this way, the subscribers can be guaranteed a specific throughput all the time because the time slots are already divided. This also scales well if you have 50 subscribers, 100 subscribers throughout your entire mesh networks. Next, synchronization. Synchronization is mainly used to control and receive the transmit power or the transmit times to prevent self-interference. What this means is either by using a GPS source as a pulse, radios can talk to each other at certain intervals to avoid collision or self-interference. The synchronization is applied automatically throughout the network. In this example, we have a bunch of nodes and half of them are marked odd polarities and half of them are marked even polarities. And based on the synchronization, let's say at time 0, all odd radios will transmit, and at time 1, the next cycle, all evens will transmit. So that way you're definitely avoiding interference from each other. So by this, you can scale up and provide higher efficiency and provide higher capacity for an entire network. Next, I want to spend maybe a few minutes talking about the overall technical advantages of 802.11 AY. The first one, as we talked about, is TDMA TDD. Basically, by moving away from CSMA CA, we definitely gain a higher spectral efficiency and also the option of reusing a frequency, so you can use the same frequency across the entire network because you are allocating the fixed time slots for each subscriber. Based on network synchronization, all radios are synchronized and they use GPS for time coordination. This will ensure the RxTX frames are aligned. This will prevent a lot of packet errors that generally happen and will minimize interference. Channel bonding, this one is the easy one. With 802.11 AY, with channel bonding, you get twice the capacity. It's because you're using twice the bandwidth of the 60 gigahertz. So you are guaranteed double throughput. For mesh routing, basically, as Dave had mentioned earlier, in a mesh type of deployment where you have a lot of nodes in close proximity, which provides some sort of redundancy built into the system, this helps in minimizing latency. It also helps in auto healing, which means even if a radio goes down, or if a couple of radios go down, the mesh routing algorithm figures out a different way to guarantee that the packets kind of flow through, regardless of a single point of failure. And also this uses the nodes efficiently, especially if you have a specific node which has a lot of load capacity. The mesh routing will ensure that different paths are taken to minimize the load balancing, to ensure the load balancing occurs across the entire network. Right. So these are the key technical advantages of 802.11ay. We also have a white paper on cambiumnetworks.com in our resource page, where we do talk about why we feel 802.11ay is emerging as a new standard for 60 gigahertz Wi-Fi. This is a much more deep dive paper, which talks a little bit more in detail and provides examples as well. I would highly recommend everyone the webinar to at least download and read through this white paper afterwards. Okay, with that, we would enter the Q&A session. I will hand it over to Alan.
Great, thank you. So I do have some questions on the question panel now. So the first question is, I think this is a question for both Dave and Sagar. You did mention about mobile backhaul. Does it mean Terragraph will support synchronization for mobile backhaul?
Sagar, would you like me to
Yes.
to start?
Yeah. Please go ahead. Yes.
Sure.
Yes.
Yeah, so Terragraph actually, the nice thing about it in terms of this use case is Terragraph units do have a GPS, as Sagar mentioned. So there's synchronization happening per node, and that's driven by the need for synchronization for the TDD, TDMA MAC scheme. But because of that, it's actually quite easy to add timing propagation mechanisms on top of Terragraph. So now Terragraph itself, as if I can call it a quasi-standard, doesn't define or doesn't require a timing synchronization protocol, but on reference platforms at Facebook, we're actually implementing 1588 specifically for this use case. So it's very compatible, I would say.
Okay, a little bit more detail on this question. Are you going to support ThinkE or 1588 clock reference? Sagar, you want to address this one?
Sorry. Yeah, I can do that. So we plan to have 1588 in the future. Syncy, we're not sure yet, but we will definitely keep our eyes open for that.
Okay, so clarify a little more. The current hardware is ready to support 1588. It will be a firmware upgrade and to support 1588 in the future. ThinkE is not supported on the current platform from Cambium. The ThinkE will require a new platform to support. Okay. Next question I have is the question for Sagar. What's your thought? What's your thought about channel bonding? It will reduce the amount of channels available, and that reduce the number of unit per site. Can you clarify that? What is the
Right.
number of usage?
Right. It's a fair question. So let's say we only have 6 channels, and everybody wants to use channel bonding. Because you're taking 2 channels instead of one, you're utilizing more spectrum which other people cannot use. This is true even in 5 gigahertz. So 60 gigahertz as well as 5 gigahertz is going to be a lot of frequency is going to be utilized. So it's almost, especially if it is unlicensed, it becomes almost first come first serve. So it's all the more important to understand 60 gigahertz and start deploying it, because the spectrum is so limited. And to your point, why we have, if we want to have more subscribers per unit, what I mentioned was we have 15 subscribers per sector, but you can have, depending on this type of radios, you can have 1, 2, 3, 4 different number of sectors per radio. So that way you can highlight it differently. Also keep in mind, you can have, if you want to use alternate frequencies, you can have on the same tower multiple, like frequency 1, frequency 2, or frequency 3, that will provide more subscribers to you without, but in that case you have to use multiple frequencies for that. But there are different ways to counter it.
Yeah, I add a little bit more details here. So if you're on the webinar last week, we talk about we're gonna release 3 different platforms, the DNV 5000 and CNV 1000 V3000. Our hardware is channel bonding ready, and channel bonding will be a feature enabled next year by a firmware upgrade. When we do the channel bonding, you simply double the capacity because you're using a wider channel. That is also why it's better than compared with AD, why the throughput is higher. Because we're using the same modulation, but we're using the wider channel. This will give us higher capacity. It doesn't impact the ratio between C and DN. If we do 115 using the single channel, we do the 115 per sector on the channel bonding as well. So every DN we can still support 30 CN as a whole because we have 2 sectors on the DN device. Okay, next question I have is what is the throughput? What is the TCP or layer 2 throughput of
Yeah,
the under the 11AY?
sure, I can answer that. So the fire rate is about, with channel bonding enabled, the fire rate is about 9.4 or 5. So it translates to about 7.5, 7.6 gigabits per second in normal. And if you double that with channel bonding, so it becomes 14 or 15 gigabits per second or system throughput.
Okay. I have a question for Dave. What do you see the market share of Terragraph, more specifically in APAC, Asia region?
Well, currently it's zero because there's not a commercial fleet of Terragraph hardware available. But we certainly will see that change once Cambium and our partners release gear in the very near term. What we expect to see following that, it's going to depend on the specific segment and so forth. So the answer today is zero, but certainly going to be ramping soon. And that's really the way it goes with a new type of infrastructure, new technology.
Good. Dave, another question. I think you mentioned about Terragraph and the moving contribution for the IEEE standard. Is Terragraph approved by IEEE?
So the way it works is, what we did with the Terragraph specification, all the information that defines Terragraph, and more specifically, all the MAC and PHY level aspects of that are actually part of the IEEE standard now, the distribution mode part of the standard. So it's one of the modes, let's say, of operation of that standard. We've contributed that to it. So if you go and look at the latest 11AY standard, you'll see contributions by Facebook personnel in there. Hopefully that addresses the question. And I would say yes, IEEE supports it in the sense that those contributions have been reviewed and accepted into the standard.
Mm-hmm. So any specific meaning of the name you choose, Facebook choose of the Terragraph?
Well, it was actually named before my time, but I would say that Terra obviously means Earth, so these are mesh networks that are terrestrial, right? And graph as in a graph network or mesh network. So you can see there's elements of the name that sort of reflect what the reality of Terragraph networks look like when they're physically deployed.
Good, good. So Sagar, question for you.
Right.
How you see the 60 gigahertz used for oil and gas industrial market?
There is definitely some potential for 60 gigahertz, especially if you want to send high capacity traffic across a short distance, especially across a oil ridge a few hundred meters, especially if you want to have a video camera, high quality, high density, if you want to measure that. There are a lot of use cases where you would want to use 60 gigahertz because it can provide such high capacity. So I definitely do see an option for that.
Okay, so there's a few questions about mesh. So one of the question is, do you expect a mesh network to be able to utilize bonding and non-bonding channels on the same network? For example, using channel bonding between some mesh node and non-channel bonding between others, depends on the bandwidth required. Do you think that is feasible?
I'll take a stab to start. So I don't believe we've actually tried a hybrid scheme like that. What we have done, at least on the Facebook side of things, as we've run these POCs, is the notion of what we would call hybrid channel networks, where you actually use more than one channel through a mesh. But we've not yet tried or conceived of a notion of blending bonded and unbonded channels throughout. I would imagine there's schemes, and I can understand the potential value in doing that, but we've just not actually pushed to that usage yet.
Right. Sagar, you want to
Yeah,
add some
yeah,
comments?
actually, I wanted to add a couple of comments. So one, as Dave mentioned, the OpenR protocol is utilized on every node or every DN to figure out what is the next best routing path, right? So even if a specific mesh network uses channel bonding, and if a specific mesh uses a single channel, the capacity will differ, but the mesh routing paths will take that into account automatically, especially if they're two separate networks and they're connected differently. The OpenR is able to figure out on, because at the end of the day, OpenR is almost like a routing table, right? So it adds weights based on every link that you go forward. So it doesn't matter if it is a channel bonded link or if it's a single layer link, the OpenR should be able to figure it out.
Okay. Additional thing I want to share here is the hardware has support both. So keep in mind when you do the channel bonding, it's gonna using two channels, adjacent channels. So literally if you run that one, you just need to make sure your channel bonding channel and non-channel bonding channel do not overlap. Otherwise, you could have some interference in the network. But you could have those things mixed in theory. As Dave mentioned, they had not tried that. We have, for our trials, we haven't done that either because the channel bonding is not a feature supported yet. It will be a feature supported next year. I think we're happy to see how it works, but in theory, it can work. A little bit more on the mesh. I think, Dave, can you tell how far you can stretch the mesh architecture? Like how many nodes can be matched before latency become too high or it cause some additional traffic issues?
Sure. Yeah, just a point on mesh before I answer it. So these Terragraph meshes, they need to anchor to a connectivity point, right? They have to get back to the internet or to a gateway somewhere. So in a mesh, there needs to be one or more what we call fiber points of presence, POPs. So, if you have a mesh with a high number of pops in it, you can keep growing that mesh because those pops aggregate capacity into it. So that's one limiting factor, right? Is how many fiber pops you have will determine how big you can grow the mesh. And that's also going to be, there's going to be a calculus there of oversubscription and what kind of end throughput objectives there are to the edge-most nodes of the network. So that's basically all to say it depends on what kinds of SLAs, service levels you're trying to achieve with the mesh. Now, as far as the size of the mesh, I think the question was right in supposing there's a latency cost to growing many hops away from a fiber pop. That's true indeed. So it depends on the application. Now, for example, a fixed wireless subscription or fixed wireless circuit may require or may be much more lenient in terms of a latency requirement. So you can get away with far more hops and a bigger mesh to a fixed wireless access subscriber versus some other application. What we've seen at least in our POC networks is we've gone to about 11 or 12 hops from a fiber pop, which is pushing it a bit, but we've not seen degradation other than the latency increasing because of those number of hops. I think sort of more typical rule of thumb, at least when we as Facebook have deployed these trials, is we try and stay to a max of 4 or 5 hops for any node.
Right. Thank you. I think I have another question for Sagar. So people is asking what is the distance and capacity using the Cambium 11AY product. Given the,
Right.
can you provide some idea about the rain zone impact? A typical rain like
Right.
region K, the 42 millimeters hour rain. What is the
Mhm.
throughput and distance for CNDN connection?
Right. Thanks, Alan. So first we can start off with, we have a V5000, which is an access point, and we have two subscribers, the V1000, which is a mid gain subscriber, and the V3000, which is a high gain subscriber. Typically for, let's say, rain zone K, which is 42 to 45 millimeters of rain, maybe up to 200 to 25 meters, you can use the V1000 and get away with the correct rain fade. Again, we have to see the link availability and 4 nines or 5 nines, but that would be an average. But if you want to extend the link beyond, let's say, 250, 300 meters, maybe to 600 meters, you would need to use the V3000. Right? And if you want to use a point-to-point network for the V, using two high gain subscribers, so the V3000 connects to another V3000. Depends again on the range zone, but easily you can get away in the range zone K with about 500 to 600 meters distance. And the
Mhm.
capacity would be about 4 gigabits per second.
Good. So as Sagar said, the 60 gigahertz given is high frequency and also the unique oxygen absorption. The distance is really depends on where you deploy and what link availability you're looking for. Good news is we have released Link Planner this week, the release 5.4. If you go to Cambium web support webpage, download the Link Planner and plot in your geo info for the link you want to deploy, you will be able to see the throughput versus distance, link availability, all the details, just like the 5 gigahertz we had. Now we add the 6 gig support there. Today is focused on the point-to-point. The point multi-point configuration will be supported later, but you can use the point-to-point choosing the V5000, V3000, V1000. That will give you a pretty good idea about throughput versus distance in your specific area by your rain rate, those factors. Okay. Another question, Sagar, for you is, can people using 60 gigahertz for longer distance, like 1,000 meters, 2,000 meters, what it will be the kind of like rule of thumb for long distance using
Mm.
V5000, using the V band radio?
Right. So typically you can use a radio up to 1 kilometer, but the capacity is going to be very minimal, right? So it makes sense for us to use multiple hops so that we get higher capacity and translate that to a high capacity over a long distance. So in theory, if you can you do a link of 1 kilometer, the answer is yes. But ideally, if you want to have 300, 500, or maybe a gig capacity, you would want to limit it to like maybe 400, 500, 600 meters, depending on the range zone, short links, and then you have multiple hops connected to it to reach that destination.
Okay, great. I think next question is for both of you. The 60 gigahertz is an unlicensed band. Um, do we support dynamic frequency selection like the 5 gigahertz?
So, I think the difference though with between 5 gigahertz and 60 gigahertz is there isn't the same radar issue there. So, to my knowledge, no, there's no need for a DFS-like scheme in 60 gigahertz. And in the stack that we work with at Terragraph, we don't do such an operation since it's not necessary.
Right. I can add to that. So typically, as Dave mentioned, yes, DFS is not enabled. Secondly, when people deploy or customers deploy 60 gigahertz, typically it's for a long haul or like a long time, right? So if somebody establishes, let's say, channel 2 in a 60 gigahertz in a specific locality, they plan to use that frequency for a very long time, right? So that
Mhm.
limits that frequency going forward. So in that sense, it's almost like first come first serve, because the person who comes in first will rarely take out their equipment and put something else, unless it's specific to the project or something like that, especially if it's like enterprise customers or residential customers. Typically they will stick with the exact frequency that they have been allocated or that is available.
Okay, great. One more question, another question, I think for Sagar. This is, you mentioned per sector, you can support up to 15 devices. What do we does this 15 include for DN, CN? How this one is allocated? And the second question is, what if I do more than 15? If I have more than, say, 16, 17 devices under the sector, how
Right.
this will work out?
Okay, I'll answer the second part first. So let's say you already have 15 subscribers connected. The 16 subscriber will not be able to connect to the V5000 or the access point. The reason being the time slots that we talked about in the TDMA TDD have only been allocated for 15 subscribers. So even if the 16th subscriber wants to connect, it cannot connect because all the time slots have already been occupied. Right. Now coming to the question of how many V5000 or how many access points can be connected to subscribers, we have we have 15 subscribers that can be connected to a DN or per sector, or you can have 14 subscribers connected to a DN and one additional DN that could act as a DN to forward or to a relay mode. Additionally, you can also have two DNs that could be connected to the main DN as along with 13 subscribers. So this gives you a lot of flexibility, especially if you want to deploy a network or grow your network dynamically, because you have an option of adding multiple DNs and kind of uh, extending the mesh network.
Right, because our for our radio, the DNV5000, we have two sectors. Every sector can support up to 2 DN to form the mesh layer as a distribution layer for the mesh structure. So, think about per sector is 2. So 1 DN, 2 sector, it will be totally 4. It will give you 4 different routes you can go, not only for network expansion purpose, it also gives you the redundant route as a mesh structure. So whatever left, it'll be used for your seeing connectivity. So if 15, if you're to make 2, then it will be 13 per sector. Okay. The next question, I have a lot of common question talk about asking about the product availability. So from Cambium, we announced the CN Wave product in general last year, and the shipping date availability, we will announce that when we're getting close. So it's coming, but we're not ready to make this available or GA date at this moment. And also question about general about the pricing, same thing, when we announce the product availability, we will share the pricing, the price structure with the customers. Next question I have is about security. I think question for Dave is how is the security, what is the security standard or works in the 11AY or Terragraph?
Sure. So we, at least on the reference design that we've done, well, first let me start by saying that the Terragraph specification or quasi standard, again, it's agnostic to that. It doesn't define a strict security type. So there's an implementation choice for any licensee of the technology in terms of how to implement security. In some of the reference work we're doing, I believe we're using a WPA3 based scheme for link security. But it will depend on the vendor's implementation choice. Alan, Sagar, correct me if you see it differently.
So Sagar, you want to comment more on this
Yeah.
part?
Yes. So our cnWave products will support AS128 encryption security on the products.
Good. So the AES-128 is basic come with the radio. You can turn it on or turn it off, up to you. And there's other security details, and you will be able to find that in our datasheet. And the datasheet will come available on the webpage once we announce the product availability. So if you just pay attention for our webinar schedules, we will get that more details reviewed in the in the coming webinars. We will announce that. I have another question here. You talked about the 60 gigahertz deployed for high density, city, urban saying. Do you see that the Terragraph technology can be used in rural deployment, Dave?
Yeah, absolutely. It really it depends on the economics, the local economics, and if fiber like connectivity is needed, but fiber is prohibitively expensive, then something like Terragraph, can be a great fit. So absolutely not the intent to exclude rural opportunities when we look at Terragraph. We've just highlighted at least our initial traction. We see it fits very well in urban, suburban, but certainly we've also looked at some rural opportunities where we see it would be a good fit.
Yeah. So Sagar, a lot of Cambium radio today is deployed to provide internet service for rural areas with 5 gigahertz. How you see the 60 gigahertz will work together with 5 gigahertz?
I think 60 gigahertz actually will play really well with the existing 5 gigahertz. The reason being the 5 gigahertz could reach areas where which has a lot of foliage or thick or which requires near or non-line of sight distances, whereas 60 gigahertz being line of sight only applications could be the last mile or the last quarter mile hop that required for high capacity backhaul for those kind of links. So I think they complement each other in a way. Especially for rural area deployment where not all areas are directly accessible, maybe due to foliage or trees or snow as such.
Okay, good. Another question on the channel support. I think Sagar, this is a question for Sagar. You
Yep.
mentioned about the channel support is channel 1, channel 4. What about channel 5 and 6? And will this support by the Cambium?
Right now, with our existing product lines, we will only support from channel 1 to channel 4. But in the future, we do plan to add more channels as we go along. But this hardware can only support channel 1 to channel 4.
Okay, great. Thank you. I think that is most question we have in the panel. Where we have 3 more minutes left. Let's see if we have more we can take one more question. Any other questions from the audience? Okay, so the webinar is recorded and the webinar will be posted under our webpage. So, and also if you have further questions regarding 60 gigahertz, please contact, we have the webpage there, contact Cambium or your local RTM, RSM, and we will be able to address your questions. Simply send an email to Cambium. The question will be rerouted to the product team, and we will get those things addressed as well. If you do have, we also have the forum available under the Cambium webpage. You can also ask your question there under the forum, and we will get those things addressed. With that, thanks everyone. Thanks Dave and Sagar. It's a great webinar. Thank you very much.
Thank you, Alan and Sagar, for having
Thanks.
me on. I really appreciate it, and thanks everyone for listening.
Thanks, guys. Bye.
Thank you. Bye-bye.